Here we are asked to find the midpoint of 2, -2 and -10, -6. So we add up our x coordinates, which are blue, and divide them by 2. Then we add up our y coordinates, which are red, divide those by 2, and we get the midpoint of -4, -4. Now this is a little different. It gives us the midpoint of ST, and it also tells us one of the endpoints, which is point T, and it wants us to find the other endpoint S. So I know this isn't exactly how it would look on a coordinate grid, but if we can just see what happened when we work backwards from 4 to 3. Well, you know you went down 1, so go down 1 more. Okay. What happened when you went from -11 to -4? Well, that's a rise of 7, so rise 7 more, and you're at the point 3. Now when asked to find the distance, we can use the distance formula. The easiest way to explain that is basically you subtract your x coordinates and square them, and then you subtract your y coordinates and square them, and you're going to ultimately add those sums together. You can see as I skipped down here and kept my parentheses, I squared the 3, I squared the -6, it'll always be positive when you square it. I ended up with 45 under the radical, and then I was asked to break it down into simplest radical form. 9 is the biggest perfect square that goes into 45, so my final answer is 3 radical 5. Okay, this is a newer topic to teachers and students this year in the course of geometry in New York State and the Common Core, partitioning directed line segments. So it's really basically, instead of just being able to find the midpoint, which is essentially a 1-to-1 ratio, we are now able to find any ratio of any segment with any endpoints. So the best way to do this once it's plotted, I believe, is look at the ratio of 3 to 5. 3 to 5 means there's a total of 8 parts, and you're looking for the third one of the 8 stops along the way. Now that we know that, I'm actually going to make a little triangle out of what is going to become the hypotenuse. My directed line segment is now really a hypotenuse of a right triangle. 3 along the horizontal and 6 along the vertical. Now I'm going to take that horizontal first, that 3, and multiply that by that 3/8, and then I'm going to take the vertical 6 and multiply that by that 3/8, and that'll get me 9/8 and 18/8. It doesn't clean up too nicely, but we could say 1 1/8, comma 2 1/4. Now that ultimately would be your answer if we had started at the origin, and sometimes you do, but this time we did not start at the origin. We started at the point 1, 4. So I'm going to add 1 to my 1 1/8, and I'm going to add 4 to my 2 1/4. Finally, I'll get the point 2 1/8, comma 6 1/4. And that is the point that is 3/8 along the directed line segment AB. Or in other words, divides the segment into a ratio 3 parts to 5 parts. Here we're asked to find the midpoint, but with literal coordinates, not necessarily numerals. So we have 3b, comma a, and -b, comma 0. I did the same thing I did before. I just added my x coordinates divided by 2, added my y coordinates divided by 2. And 3b plus -b is 2b, and a plus 0 is a. Simplify the 2's on the left side there, and my final answer for a midpoint here would be b, comma a over 2 in simplest form. Now here is really kind of a coordinate proof, but with literal coordinates again. So this would be a little cumbersome to go through every single step. So I have it all done out, and I'll explain how I went about it. In order to find the slope and distance of each segment, I used the slope formula for every pair of points that would make a segment, and then I used the distance formula for every pair of points that would create a segment. And I noticed as I went through this, I had a slope of 0 here and a slope of 0 here, meaning I had parallel sides. I also had a slope of 2b over a and another slope of 2b over a, meaning I had a second set of parallel sides. In addition to slope, when I found distance, I found I had a distance of a, whatever that is, but I had another distance of a. So I also had a pair of congruent sides here, and then another weird looking but still congruent set of sides, radical a squared plus 4b squared, and another radical a squared plus 4b squared. So I had two sets of parallel sides, and I had two sets of congruent sides. So question E down here, based on the above calculations, what shape is formed? Well, that would be a parallelogram. It doesn't necessarily look like that purple example at the bottom, but that could represent it. Two sets of parallel sides and two sets of congruent sides.